Hey folks, Bill Armstrong here. Even though I supplied you answers for the practice test for test 1, I thought I'd work through solutions for some of these items so you can see the work through solutions as well as the answers. Here in number 1, you were asked to solve this linear equation, and what I would do in solving this is I would multiply both sides of the equation by the least common denominator of all the fractions I see. And when I look at this equation, I see a denominator of 3, denominator of 4, so the LCD, least common denominator, is 12. And I would multiply both sides of the equation by 12. So let me write that step in here. And then use the distributive property over here on the left side. 12 times 1/3 x is a 4x. So 4x. 12 times 3 is 36. Distribute the 12 over here. 12 times 1/4 x is 3x. And 12 times the negative 7 is negative 84. I would subtract 3x from both sides, and that would give me an x plus 36 equals a negative 84. And finally, subtract 36 from both sides of the equation to get x equals, negative 84 minus 36. It's a negative 120. And that's what you should have for number 1. All right, hey, the next one I thought we'd look at is number 3. And number 3 had two parts. In part A, you were asked to basically multiply this out and write your answer in the form A plus BI. So it's the complex number form, A plus BI. Well, in doing this one, I would attack it, well, the way I would just multiply binomials together. So I'd do the FOIL method. 4 times 2, that's 8. 4 times a negative 9i, that's a minus 36i. 2i times 2 is a 4i, and then 2i times the negative 9i is a negative 18i squared. Now I can treat these as like terms, and I can combine them. So I have 8, negative 36i plus 4i, well that's a negative 32i. And then remember that I squared is equal to negative 1. So I'll substitute negative 1 in for the I squared. And then cleaning it up, negative 18 times negative 1 is a positive 18. And then finally, 8 plus 18 is 26. So my final answer is 26 minus 32i. That's the A plus BI form. So hopefully this is what you have for 3 part A. All right, hey, here in 3 part B, we're supposed to do the same directions, write it in the form A plus BI. We have to simplify this down. The first thing I look at is the square root of negative 245. I can think of that as being the square root of negative 1 times 245, where the negative 1 times 245 is under the radical. And the square root of negative 1 is I. So my first step here is to get the I out of there. Okay, next in simplifying, I'm going to try to find a perfect square that is a factor of 245. So a perfect square like 4, 9, 16, 25, 36, a perfect square. I think the largest perfect square that is a factor of 245 is 49. I believe you'll find 49 times 5 is 245. So if I write the square root of 245 as 49 times 5, well, I'm almost there. I have negative 7 minus I, square root 49 times 5. The square root of 49 is 7. So this gives me negative 7 minus 7i square root 5 all over 7. And then, let me tag this on up here. If I look up here in the numerator, both of these terms have a factor of 7. So I'm going to go ahead and factor a 7 out. That'll give me a 7 times a negative 1 minus I square root 5 all over 7. And since I was able to factor a 7 out, I can now cancel out the 7. So let me get this pink colored chalk, cancel out the 7s, and I get as my final answer negative 1 minus I square root 5. Hopefully that's what you have for 3 part B. Hey folks, here in number 4, you were asked to use the quadratic formula to solve this quadratic equation. So if we do that using the quadratic formula, remember that you have to remember the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that junk over 2a. And it's just a matter of substituting in. B is 10, so the opposite of 10 is negative 10, plus or minus the square root, b squared, well, that's 10 squared. 10 squared is 100, minus 4 times a times c. Here's a, here's c, so 4 times 5 times 2. 4 times 5 is 20, 20 times 2 is 40. So 4 times a times c is 40. And all of that is over 2 times a. A is 5, so 2 times 5 is 10. Cleaning this up, we have negative 10 plus or minus the square root of 60 over 10. And again, what I'll try to do is I'm going to try to simplify this radical. Square root of 60, I'm going to try to find a perfect square that will be a factor of 60. And I think 4 is. I think 4 times 15 is 60. So if I just rewrite this now as negative 10 plus or minus the square root of 4 times 15 all over 10. And let me just rip that on up here. Square root of 4 is 2, so we should now have negative 10 plus or minus 2 square root of 15 all over 10. And like I did in 3 part B, in the numerator, I see 2 as a factor of both of those terms. So if I factor out a 2, I'm left with a negative 5 plus or minus the square root of 15 all over 10. And then 2 will cancel into the 10 and leave me with a 5 in the denominator. So I have negative 5 plus or minus the square root 15 over 5. Or I think as I had it written, well, maybe I had it written like this. This is fine as an answer. If you wanted to go any further, you could write this as negative 1 plus or minus the square root 15 over 5. That's if you wanted to go further. I am more than happy with that as the answer. So you have 2 solutions here. X is negative 5 plus square root 15 over 5, and x is negative 5 minus square root 15 over 5. So hopefully that's what you have for number 4. All right, hey, here in number 5, you were asked to use the discriminant to determine how many solutions and what type of solutions you have here. I guess the key here is to remember what the discriminant is. The discriminant comes from the quadratic formula, and it's literally the stuff that's living under the square root sign in the quadratic formula. So if you look at the quadratic formula, you will see what's under the square root is b squared minus 4ac. This is what is known as the discriminant. So all we have to do is compute the discriminant here. B is 6, A is 8, C is 6. So if I substitute those in, I get 6 squared minus 4 times 8 times 6. That's 36 minus, 4 times 8 times 6. That's 192. So 36 minus 192, that's a negative 156. So the discriminant has a negative value. It's negative 156. When the discriminant is a negative, this tells us that we're going to have no real solutions. In fact, we're going to have two complex solutions. So the answer here is no real solutions. There are two complex solutions. Just remember the following. Your discriminant. The discriminant is b squared minus 4ac. If that is a positive number, if you end up getting a positive number, something that's greater than 0, that tells you you have two real solutions. If your discriminant, b squared minus 4ac, well, if it ends up equaling 0, that tells you you're only going to have one real solution. And then finally, as we just saw here in number 5, if the discriminant is a negative number, that tells you you have no real solutions, but you have two complex solutions. So that's kind of like a quick review, a quick summary of what the discriminant and the value of the discriminant, what it tells you about the solutions. So hopefully here in number 5, you had the discriminant computed to be a negative 156, which told you have two complex solutions. And that's it for number 5. All right, hey, here in number 6, it's a word problem. You have someone's doing a physics experiment, and they're dropping a baseball from the top of a 315-foot tall building. To the nearest tenth of a second, I asked you to determine how many seconds will the ball fall. So, think about this. If I'm dropping this baseball from the top of a 315-foot building, as soon as I let go of the ball, someone starts a clock, a stopwatch. We want to know how long will it fall. So that means how long before it makes it to the ground. How long for it to travel 315 feet, because the building is 315 feet tall. Gave you a hint here. I said use the formula h equals 16t squared. And I told you that this formula gives the distance h in feet that a free-falling object travels in t seconds. So this is the formula that will tell us the distance h in feet that this baseball is traveling in t seconds. Well, we want the baseball to go from 315 feet, the top of this building, to the ground. So we want this baseball to travel 315 feet. We want to know how long it takes the baseball to travel 315 feet. So what you're really being given here is you're being given that h is 315. That's the height of the building. That's how far the baseball will fall. So you put 315 in for h. And this is the equation that you have to solve for t. That'll tell us how long it takes the baseball to travel 315 feet. I would divide both sides of the equation by 16. And then I'd use my calculator and I'd do the square root. Now, technically speaking, when I do the square root of both sides of this equation, I get a plus or minus, but we're not time travelers, so we shouldn't have a negative value for t, a positive value for t. And if I use my calculator and do 315 divided by 6, I take the square root of that answer, I get t to be pretty close, or rounded to the nearest tenth, to be 4.4 seconds. That's it for number 6. Hey, here in number 7, I asked you to solve this equation using the factor by grouping technique. Generally speaking, pretty straightforward. You put the first two terms in a group, and you're going to put the second two terms in a group. But be careful that when you put the second two terms in the group that you get the correct sign here. You know, keep in mind if I ask you to use the distributive property here to get rid of parentheses, you'd be distributing a -1, which would give you what we originally started with. If ever a mistake is made on a problem like this, it's usually with this sign right here. So just be careful. Continuing, in this first group, common factors x squared. So I could rip out an x squared, and that leaves me with an x plus 5. In this group, a common factor is 16. And that will leave me with an x plus 5. Now in this term, you should be able to see that x plus 5 is a common factor to both of these terms. So I can factor out the x plus 5, and I'm left with x squared minus 16. And hopefully you all remember that x squared minus 16 is a difference of two squares, and that factors to x plus 4 times x minus 4. And then we could set each factor equal to 0 and get our solutions. So we'd have as our solutions x is -5, x is -4, and x equals 4. So those are the three solutions to this equation. Hopefully you got that, and hopefully everything's going really smoothly for you on this practice test at this point in time. But that's it for number 7. Hey folks, here in number 8 I asked you to solve this equation that involves a radical. Generally speaking, when you have a radical involved in the equation, you want to do the process called isolate the radical. That means get the radical on one side of the equation all by itself. It already is. Once you have that radical isolated, what we're going to do now is we're going to square both sides of the equation. So when I square the left side and I square the right side, well, squaring the left side just leaves me with an 18x minus 27. When I square the right side, remember this is x plus 3 times x plus 3. I should get an x squared plus a 6x plus a 9. And now I want to get all the terms, I want to get everything on one side of the equation, and I want to get 0 on the other side of the equation. So I'm going to subtract 18x from both sides, and I'm going to add 27 to both sides. So I get 0 is equal to x squared. See, 6x minus 18x, so 6x minus 18x is a -12x. And then I add 27. 9 plus 27 is 36. And I'm going to try to factor the right side of the equation. So when I try to factor, so I have an x here, an x here, a minus plus means both of these signs are subtraction. I think it's just this, minus 6 minus 6. Set each factor equal to 0 and solve, and I get only one solution, x is 6. Hey, now remember this, when you do the process of squaring both sides of an equation, you really need to check your answer. Make sure that it works. Make sure it's not bogus or the official mathematical name for it is extraneous. But I think if you put 6 in here for x and in here for x, you will see that the solution checks. That's it for number 8. Hey folks, here in number 9, I asked you to solve this linear inequality and write your answer in interval notation. So to solve this linear inequality, we start off how we would solve equations. Want to get x on one side of the inequality symbol by itself. I would start off by adding 5x to both sides. So -4x plus a 5x gives me x. And then I would subtract 6 from both sides to get x is greater than or equal to 2. So in interval notation, I can pick any value of x that is greater than or equal to 2. Any value of x greater than or equal to 2 will be a solution to that linear inequality. So the interval notation for it is square bracket 2, comma, infinity. Quick review here on when to use a square bracket versus when to use a parenthesis. First off, if you ever have infinity or negative infinity involved in your answer, that would always have a parenthesis around it. There is no largest number. Square bracket is used to mean the endpoint is included. And it matches up with this kind of inequality sign, the greater than or equal to or the less than or equal to. So if you see that or that, square brackets are going to be involved because that means you're allowed to include the 2. It's the or equal to 2. You're allowed to include the 2. If you see that inequality or that inequality, then it would be a parenthesis. I call that a strict inequality. So if I have x is greater than 2, there is no or equal to, just x is strictly greater than 2. The interval notation for this would be parenthesis 2, comma, infinity. Not a square bracket, but a parenthesis here. But for number 9, I hope you had this as the solution, and I hope you have this as the interval notation. That's it for number 9. All right, hey folks, here in number 10, I ask you to solve this absolute value inequality and write your answer in interval notation. I would begin this one by subtracting 6 from both sides to get absolute value of x minus 5 is greater than or equal to 9. Now, since it's a greater than or equal to 9, it's a greater than or equal to, the way we set up to solve an absolute value inequality when we have the greater than or equal to, I write down that x minus 5 has to be greater than or equal to 9, or the x minus 5 has to be less than or equal to negative 9. I solve this by adding 4 to both sides, adding 5 to both sides, and I get x is greater than or equal to 14. And I solve this by adding 5 to both sides to get x is less than or equal to negative 4. So now I write my answer in interval notation. So in interval notation, what would match up with this? X is greater than or equal to 14. It would be square bracket 14, comma, infinity. What matches up with this? X is less than or equal to negative 4. It would be parenthesis negative infinity up to negative 4 square bracket. And here's how I'd like you to put these together now, these two interval notations, into like a final answer that would look something like this. Negative infinity to negative 4 square bracket union with square bracket 14 to infinity. So Drew is here and that is here. But this is how we would write the answer in interval notation. Hopefully you got that for number 10, because that's it. Hey folks, here at number 11, I asked you to solve this, it's called a rational inequality. Over here on the left, that's a rational looking thing. It looks like a fraction. And there are many ways to do this. I'm just going to show you the way I do it. For me, the key is to look at the numerator and look at the denominator and find those values of x that would make the numerator 0 and the values of x that would make the denominator 0. Well, the denominator will be 0 at x equals negative 8. The numerator is 0 at x equals 9. That's where I begin. I will make a number line. And on the number line, I'm going to list the values of x that makes the denominator 0 and the values of x that makes the numerator 0. So the denominator is 0 at negative 8. The numerator is 0 at 9. Okay. Notice that these two values of x have split the real number line into 3 intervals. The interval from negative infinity to negative 8, the interval from negative 8 to 9, and the interval from 9 out to infinity. Next, what I do, I just kind of call this bookkeeping. It keeps my work neat and organized. Over here to the left, I'm going to list the numerator and the denominator. So I'm going to put x plus 8 here, x minus 9 here. And then I kind of got into the habit of making like little dashed lines like this. And then I find where my numerator and denominator were equal to 0. In other words, x plus 8 was 0 at negative 8. So x plus 8 has a value of 0 at negative 8. X minus 9 had a value of 0 at 9. And then here's the trick. In this interval from negative infinity to negative 8, pick a value of x that you know is definitely in this interval. I'll pick x as negative 10. Put negative 10 in here for x. Negative 10 plus 8 is negative 2. I don't care that it's actually a negative 2. All I care about was that it was a negative that came out. So I put negative. For any x that I pick in this interval, x plus 8 will be a negative number. If I pick negative 20, negative 20 is in here. Negative 20 plus 8, it's negative. Put negative 10 in here for x. Negative 10 minus 9 is negative 19. It's negative. No matter what value of x I pick in here and put it in here for x, a negative number will come out. I move to the next interval. Negative 8 to 9. I pick a number that I know is definitely in this interval. I would pick x equals 0. When I go through the same process, I put 0 in here for x. What kind of number comes out? Positive or negative? Well, a positive number comes out. So no matter what number I pick in this interval, and I put in here for x, a positive number will come out. I put 0 in here for x, and I get a negative to come out. And then finally out here in this interval, 9 to infinity, again, I can pick any number I want. So I'll pick x equals 11. Put it in here for x, out comes a positive number. Put 11 in here for x, out comes a positive number. And now here's the key. Look at your original inequality. You're taking x minus 9 and dividing it by x plus 8. On this interval, negative infinity to negative 8, x plus 8 is negative, x minus 9 is negative. Negative divided by negative divided by a negative will be positive. On this interval, x minus 9 is negative, x plus 8 is positive. Negative divided by a positive, well, negative divided by a positive is negative. And finally, out here in the interval 9 to infinity, x minus 9 divided by x plus 8, that would be a positive divided by a positive, gives you positive. It's this line right here that will answer any inequality. I want to know the answer to when this quotient, x minus 9 over x plus 8, is greater than 0, when it is positive. Looks like it's positive on this interval, and it's positive on that interval. So my answer, negative infinity to negative 8, union with 9 to infinity. And notice parentheses around the negative 8 and a parenthesis around the 9, because the inequality is strictly greater than. It's a strict inequality. If it had been greater than or equal to, Well, then you would just have a square bracket around this one here, not around this one because you can't have 0 in a denominator. But in summary, it's this line right here that would answer the question. And hopefully you have this as your answer for number 11. That's it for number 11. Hey folks, here number 14. I was skipping 12 and 13, going to 14. You're supposed to do part A. This was part A. You are supposed to find the point-slope equation for the line that has a slope of -8/9, and it passes through the point 4, 4. So let's see here. Point-slope form. I suppose we need to remember point-slope form is y minus y1 equals m times the quantity x minus x sub 1. And then just substitute in. Y sub 1 is 4. So you have y minus 4 equals -8/9 times x minus, and x sub 1 is 4. And this is your answer in point-slope form. I want to extend this a little bit. What if I asked you to write your answer in slope-intercept form? That means I wanted it in the form y equals mx plus b. Well, you'd have to do a little bit of work to put this into y equals mx plus b form. Like distribute the -8/9 and then add 4 to both sides. And let's see, if I add 4, I'd need a common denominator, which, boy, it'd be 9. So I think I'd get 68 over 9. Yeah, add 4 to both sides. This is the answer in point-slope form. This here is the answer in slope-intercept form. But as the directions were written in 14, part A, that's what you should put down as your answer. And hopefully that's what you had for your answer for 14 part A. Alright, in 14 part B, you're asked to graph this line and find the intercepts, the x-intercept and y-intercept, and label the intercepts. So you just remember to find the y-intercept, you're going to let x equal 0. So you put 0 in here for x. You have 5 times 0 plus a 3y equals 15. 3y equals 15. Divide both sides by 3. You get y is 5. So the y-intercept is 0, 5. To get the x-intercept, you let y equal 0. So you put 0 in here for y. So you have 5x plus a 3 times 0 equals 15. 5x equals 15. Divide both sides by 5. You get x is 3. So the x-intercept is 3, 0. And then to make the graph, I just need to plot these 2 points. Point 0, 5 is right here. And the x-intercept is 3, 0. So that's right here. And that would be the graph of the line. So hopefully you have that for the y-intercept, you have this for the x-intercept, and this is the graph that you came up with. That's it for 14 part B. Okay, here in number 15, you're asked to come up with an equation of a line that is perpendicular to the line 5x minus 6y equals -2, and it goes through the point 0, 3. first thing we're going to have to do is we're going to have to determine the slope of this line. So to get the slope of that line, what I will do is I'm going to take this equation and I'm going to solve it for y. That'll put it into y equals mx plus b form. And to do that, I'm going to subtract 5x from both sides. And then divide both sides of the equation by -6. And I can now read that the slope of the line is 5, 6. That tells me that for a line to be perpendicular to this line, a perpendicular line must have slope of -6/5. Remember, two lines are perpendicular if when you multiply their slopes together, you get a result of -1. So now that I know the slope of the line I'm trying to find is -6/5, I now look at this bit of information. It has to go through the point 0, 3. That's the y-intercept. So if I just use my slope-intercept form, I know the slope has to be -6/5, so I put -6/5 in for the slope. The y-intercept is 3, so b is 3. So there is that's the equation of the line in slope-intercept form. Now in the directions I asked you to put it into a standard form. So we just have to manipulate this a little bit. We have to get rid of the fraction for starters. So if I do that, I can just multiply both sides of the equation by 5 to get 5y equals a -6x plus 15. And then add 6x to both sides. Gives me 6x plus 5y equals 15. This is fine. Or some of you may end up with -6x minus 5y equals -15. These are equivalent. Either one of these would be acceptable for the standard form. You know, most people I think would probably like this because nothing but positive numbers. And to be perfectly honest, the form that I like best is this, the slope-intercept form, because that tells me everything I need to know about the line. But in any event, that's it for number 15. Make sure that you know two lines are perpendicular if the product of their slopes is -1. And I guess you should know also that two lines are parallel if they have the same slope. But again, that's it for 15. Hopefully you got it. That's it for the video solution to the practice test number 1. Hopefully you're feeling comfortable and confident for test 1. Thanks for watching.